Chapter 19, Testing Hypotheses about Proportions. This entire unit is taking us from looking at what data is, the collection of the data, the display of the data, and the interpretation of the data, to making some sort of assumption or conclusion about the world at large. We have done that by looking at sampling distribution models, what happens when we take frequent samples, what do we expect to occur, as well as creating confidence intervals, which basically state, based off of my current sample, my current statistic, what do I think might be true about the population based off a certain confidence level. In hypothesis testing, it's very important that you clearly show all of your work and you clearly explain every step of it. It's the idea of your boss asks you a question and says, okay, I want you to go out and answer this question for me. But you don't just give him, oh, I think the number of extra large t-shirts we should sell or we should have purchased is 10. You need a little bit more than that. You need to be able to justify where that number came from, why you're making the recommendation that you're making, and that you've shown that you've thought the process through clearly. So when we're doing a hypothesis test, there are 4 main steps that you have to show on every single hypothesis test in order to get credit, or really in order to have a correct and accurate hypothesis test, regardless of AP or not. The first one, well, this is a hypothesis test, so you should probably start with a hypothesis. We're going to go into what that actually entails in just a second. The next thing is your model, and that's what we've been talking about when we say my sampling distribution follows a normal model with a mean and a standard deviation. You absolutely have to incorporate that. The mechanics is not just doing your mechanics, but stating which test that you're going to do, as well as justifying that you can in fact do that. And the final step is your conclusion, which, if you haven't already guessed, is supposed to be in context. Context, context, context. Now, these 4 pieces, hypothesis, model, mechanics, and conclusion, are extremely important and must be shown for every single problem that you do. It may be something you want to memorize. So going into detail for each of these, this is an extremely good opportunity for you guys to take notes, fill out your flip books if needed, but to really take time to get these things written down. We're not going to have time in class to do that. We're going to go straight to the discussions and straight to working problems. All right, so my 4 parts of a hypothesis test begin with the hypotheses themselves. Now, in our hypotheses, we have something that is called a null hypothesis, and that's basically either our previously held belief or what we think is true. It's got to be in terms of whatever parameter I'm trying to measure. So I believe the proportion of high school students who are enrolled in AP classes is 20%. So my hypothesis is that that proportion is 20%. So here we have in general, this is what we'll say the parameter is equal to the hypothesized value. Now what we oftentimes will do is we will say something along the lines, for this unit we're talking proportions, so I'm going to believe that the proportion is equal to some value. But we have to identify what that P stands for. The alternative hypothesis is usually what we're going for. What are we trying to show? If I believe that there is a change, then I'll say not equal to. If I believe that there's an increase, I'll say greater than, or a decrease, it'll be less than. So the model itself consists of many things. First off, you have to actually specify what model you're going to use. But basically it's saying what type of distribution are you going to use? Remember, shape, center, and spread. Right now, we're going to be using the normal model. There are other models that we will get to, including the t-distribution and the chi-squared distribution. But right now, we're just talking about normal distributions, which have a mean and a standard deviation as the parameters that I'm interested in. So here you can see that we've placed state any assumptions and conditions, because in order to talk about that model, you have to first have those incorporated. And your final step, your final thing must be a statement such as this: condition satisfied. Sampling distribution is going to be a normal model, just like what we've been doing. This model stage should not differ at all from what we did for our confidence interval on proportions. Now, if you don't meet your conditions, you'll say something along the lines of conditions are not met. You cannot proceed with the test. Same thing if our conditions were not met for a confidence interval, we would actually stop unless they insist we go forward, and then we say, be very, very cautious. I don't think this is going to work. Now, here's the specific thing. Every single test that we're going to do, we've started with 1 proportion Z intervals, but all of the tests that we use, either intervals or hypothesis tests, must be labeled according to whatever test we're performing. So here we're going to be talking about the 1 proportion Z test. And so you'll notice that these phrases are very important because they will be pretty much identifiers for which test in your calculator you use. So for the 1 proportion Z test, each of these tests have slightly different null hypotheses, alternative hypotheses, and conditions. The null hypothesis, and this is the notation for the null, that is what we call the null. Sometimes it's going to be, and that's usually an H sub 0 is what that is. So we'll say H sub 0 is the null hypothesis. And we will have some tests saying, I believe the true population proportion is something that I'm associating with the null. That subscript of 0 is always talking about the null. You have your test statistic. You have to show this. In a confidence interval, we're using a Z star that goes with a specific confidence level. For this, I need to make sure that I use my Z calculated based off of my observed statistic, what I predicted would occur, and the standard deviation. Now, you want to make sure that when you talk about this, that you think of it in the terms of observed minus predicted divided by the standard deviation calculated with the predicted value. For a confidence interval is centered on what our statistic is. It's only talking about what we have already accomplished. A hypothesis test is a test about the hypothesis, my null hypothesis to be exact. So you want to make sure that you incorporate that. So when you have conditions met, null hypothesis identified, basically what we do is we apply a normal model and we look for something called a p-value. Now the mechanics go into finding that specific p-value. This is everything that we need to calculate the test statistic. That includes different formulas for different tests. For our 1 proportion Z test, we get to use the calculator, which is extremely nice, but we still need to make sure that we list everything that goes into it, and you have to indicate that you understand what the formulas are, and our notation allows us to do that. So in order to obtain this p-value you can think about it as your probability. What you're going to do is you're going to calculate the probability that your observed statistic, or something more extreme, we've talked a little bit about that, or more extreme, would occur if the null were correct. So basically what we're looking at is we're looking at the probability that my test statistic, sometimes that'll be not equal to, greater than, or less than, and then whatever my value was from the null hypothesis. That is what we're looking for. That is the p-value. We've actually already computed those in other cases. When my p-value is small enough, and we've talked a lot about what small enough is, and we've used this value of 0.05, that allows us to reject the null hypothesis, or state that we have evidence to show that what we previously thought to be true isn't, and that we're leaning toward an alternative outcome. Now, the p-value. Here's another really good question or statement that you should memorize. Remember I told you that there would be 10 sentences that you need to memorize over the course of the year. The first one was interpreting a confidence interval. Then we had interpret a confidence level. And now here we have interpreting a p-value. The p-value is the probability that the observed results could have happened if the null hypothesis was true. Now, basically what we're going to be doing from here on out, and I'm just going to give you a warning right now, you are going to have a lot of those little quick check pop quiz type things where I ask you one question and you write down the answer. We're going to be rotating through all of these sentences that I expect to have you memorized. So one day you might have interpret a p-value and the next day you have it again. Or maybe you have interpret a confidence interval or interpret a confidence level. These are all statements that you have to have memorized. The final part of our hypothesis test is the conclusion. Now, our conclusion is always reflecting our decision that we've made about the null hypothesis. And it's always centered around, do we reject it or not? So you can either say that we reject or we fail to reject. Don't ever say accept. Accept is not really a 5-letter word. It's a 6-letter word, but it's still bad. Do not say we accept the null hypothesis. Basically, all we're saying is that we don't have enough evidence to toss it out. So it might not be true, but we can't comment on that. We can only comment whether or not I think it's false. You always must tie your decision to your p-value. And that p-value will be compared to our significance level, which we call alpha. We've talked a lot about that 0.05, the likelihood of something as extreme or more occurring being less than 0.05 to say it's unusual. That 0.05 is our standard alpha level. It may change depending upon very similar to our confidence level, and they're tied directly to it. But generally speaking, when it's not noted, we use an alpha of 0.05. So if my p-value is less than 0.05, we reject our null. And then we finally tie it all together with a description, a context-based decision. So we would say something like, with a p-value of 0.02 being less than alpha of 0.05, we reject the null. Our evidence does not support the conclusion that 20% of high school students take AP classes. So you always make a p-value and decision statement, reject or fail to reject, p-value tied to alpha. And then your next sentence is always about the context of the problem. Now, if you reject, you have to state that you have evidence to believe in the alternative, HA. Sometimes that is written as H sub 1. So we have the null and we have the alternative. The null is 0, the alternative is either A or H sub 1. So if my p-value is less than alpha, here we're thinking about that 0.05, then we say that we have enough evidence based on our sample to say that the null hypothesis is not true. Or if we fail to reject, then we say we don't have enough evidence to go for the alternative hypothesis. Be sure that for the next class, you have the main 4 components of a hypothesis test at least down in your notes. And if not understood and memorized, that really is important, then at least a list of questions that you have. We're going to really tear this apart and hopefully make sure that you understand what all of our pieces are, how to write a null and alternative hypothesis, how to talk about your null distribution, or what your sample distribution looks like, including how to check your assumptions and conditions. We're going to go into what mechanics in specific are shown for a 1 proportion z test. And then how do we really tie those mechanics to a conclusion and put that conclusion in context. Okay. See you next class.